Hi, everyone. So this is work I did with a student who was here in my lab for the summer. She's from our Rochester Institute of Technology. Her name is Ashley Lee. She couldn't come here, so I'm presenting her work. So this was motivated by these kinds of problems we had, right? When you look at these captions in our publications, right, they're usually very miserably small. So this is actually one from my own paper, the battery data set visualized with Radvis, okay? And then there's another one from the same paper, the battery data set visualized with Radvis Deluxe, which is the other thing. And then there's another paper that I wrote, Pareto optimal graph spreading. It doesn't really say anything. What the problem with this is, these are my own papers, okay, making fun of myself, okay? Don't be offended. So basically, this is geek speak, right? There's nothing really in there that tells anything about the data at all, right? And the data domain is not connected at all. This is just a bunch of engineers talking to another audience engineers, but it doesn't really show anything. What actually these data are very exciting, but don't talk about it all, right? So when you look at this, and this you can read the study by Michel Borkin, right? It's really a good study. They showed with user experiments, they showed that actually paragraph and title and label, paragraph is actually the third most thing that people recall, right? It's the data comes after. That's amazing, right? The data comes after. So because you look at this caption, and then you look at the data if it's actually true, right? This is sort of my thinking, at least, of it is. So so how can us geeks become these cool journalists that write these beautiful captions that are so engaging, right? How can we do that? So luckily there's something called GPT-3, and already heard about this before, right? There's this how that can save our butts, okay? So GPT stands for third generation generative pre-trained transformer. So it's a language prediction model, right? So it's like basically think autocomplete on steroids, right? It's the ultimate autocomplete. And what it does really, it works in a next token generation process, right? It basically, you give it something and then it tries to predict the next word based on probabilistic reasoning, right? So from all the corpus, it tries to find that word that fits best after that, right? And then it puts that there, and then there's the next token it predicts and so on, right? So the number of tokens that are allowed with GPT-3 are with the input and what it outputs. So it determines the cost. Actually, you have to pay for this after a while, and the time it takes to actually get the caption. So you'll have to be very very, very attentive to how much input you actually provide to get the right output. And this is called prompt engineering, right? So the prompt engineering is actually the key task in this. So our initial experiments were like basically GPT-3 doesn't really do well with numbers and aggregate things like that. So if you give it some numbers, it doesn't really know what to do with it, right? I think I read somewhere GPT-3 can even predict that 3 comes after 2, stuff like this. So you need to do some analysis before you give that to GPT-3. Okay, so next thing. So we provide basically this kind of information. We take this, we use only scatterplots. What we do basically, we provide regression coefficients and outliers and Pearson's formation and the number of clusters. So we give it some stuff to deal with, so it doesn't have to infer it itself because it can't, right? So we give it some stuff, and then we have these 3 tiers of prompts, right? We basically, the first tier is just a template. Any template that can be auto-filled with these measurements we take, and there's no human input at all, right? We just analyze the scatterplots, we fill the template, done. And then the tier 2 is the template and some instruction, like a little bit, some sentences that describe the specific talking points that we'd like GPT to ramble about. Okay, there's a little bit some human effort needed. And then the third one is where we really engage in the question answering. We really do Q&A with GPT. We start to converse with the bot, right? So that takes more time. So give you like an example of this tip here. So we took like scatterplots like this. This is GDP per capita versus healthy life expectancy. And as you can see, a nice correlation. There's like Swaziland, like an outlier. We detected that. And then we went and created our first prompt. Basically, the first prompt was just this template that I show here, like just a regular template filled in with the stuff we measured, and we added some stuff in there, like other attributes that are in the data set to give some context, right? We heard about the context in the keynote. Basically to give a little bit of context, what actually is the data all about, right? Not just the attributes only that we had. that we had the scatterplot about, and all these information that we expect that we got out. And the generated caption we got in tier 1, just throwing the template at the GPT-3, we get the higher GDP per capita, the higher the healthy life expectancy, exclamation mark. Well, it's a beautiful caption, right? A little bit witty and smart-assy kind of thing, but it's a good start, right? So we knew we had to do a little more than this, right? So the promo 2, right? So we've added basically to the prompt that we had, we added this, like the prompt that you saw before, the long templated prompt. The caption should include information explaining causes of the large positive correlation, why there is an outlier in detail. So we just added that and just throw it at GDP. And then we really got something very, very nice, right? Look at this, right? Strong positive correlation. And then we heard about outliner data Swaziland, which is a lower healthy life expectancy than would be expected. This is likely due to the high prevalence of HIV in the country, which has significant impact on health of the population. Beautiful, right? This is actually something you get, you read like a paper news, like a New York Times article, that's what you would get, right? Like a nice explanation that you probably have to research if you didn't have GPT-3, right? Beautiful. And then, so it becomes a data journalist now. Then we want to dig a little more, right? Added some more prompts, like we added more stuff to the prompt that I should show you. Are there any other reasons why Swaziland has a lower healthy life expectancy? Why does Swaziland have poor sanitation? Why is the reason? So it basically was prompted by the GDP, what it returned to us, right? And then we got a little more out of it. Swaziland's poor nutrition is likely due to a combination of factors, including poverty, food insecurity, and the lack of access to nutritious foods, right? So it's, this is a nice caption, right? It's a little long, but it's has some, you learn something from this caption, right? Something you couldn't get from the visualization itself, which is a good thing, right? So what we found out was there's this something called temperature parameter. When you set it to 1, we set it to 0 initially, but you also set it to 1, which basically gets more diverse response. Every time you run GPT-3 on a prompt, you get a little bit of a different response. So it takes more risks, they say, right? And then sometimes, however, what we also found out, sometimes it gets confused, right? And sometimes actually it's not true what it returns. When you do some fact checking, you find out it's actually not true. So we discovered that. And we couldn't blame it, of course, but there's no one you can slap. Like claiming, for example, as one thing, that size is the same even though the data attribute area increases, right? There was one plot like that. So, so it couldn't figure out that size and area are related. It didn't know that, right? It only knows so much. And the bot will also not elaborate. Even when you prompt to do like, tell me more, very, very impatiently, he wouldn't say more. Right, because it didn't learn, I guess, or something like this. So there's more examples in this paper that we have. Then we did a user study, and we showed 11 participants were shown 4 visualization in turn, and they saw all the 3 tiers. And then they were asked to rank them. We found out that tier 2 and tier 3, in terms of the engaging, because engaging was our prime hypothesis, so I want to see if we can actually get more engaging captions out of them. Tier 2, 3, all rank the same. In terms of the relevance, tier 2 and tier 3 were almost the same too in terms of relevance, what it gave out to the data, I guess. And then 2 more we did on the repetitiveness. So of course the last tier was more repetitive because it was more text, right? Okay. And then novelty ranking, tier 3 won again because it did give more novel information out, right? So that was good, right? So here's some other one that we did on this. This was more of a cluster-oriented visualization, and it describes all this stuff here. And it was on average income over spending score. Okay, and then it talked about lots of things about this, but I really want to highlight this. These outliers could be due to a variety of factors, such as customers with high incomes who are thrifty, or customers with low incomes who make impulsive purchases. I think that's a beautiful sentence, right? It's like really, really interesting, like something that really only a journalist would write, right? I mean, okay, maybe you guys could write that too, but it's like something you would expect in an article from like in a general magazine or newspaper, right? So, and I open up the floor to questions. Okay, so this is my last slide.
Marty Hurst, UC Berkeley. This is a really interesting presentation. because I'm quite interested in how language models are going to affect Viz. I'm wondering if you experimented with varying what kind of input you gave the model. I know you were, in terms of how much of the original data, because you said you use outputs of regressions, coefficients, that sort of thing.
Stop that.
How important was it for you to describe that data, do you think, for this interpretation?
Oh, it was just in that template was in there, and then we dug a little deeper, right? We used this. So when it didn't return what we wanted, we basically say, tell me more. Why do you think the regression, or why do you think the rise is higher? What makes you think that? Right? Try to tease it a little bit so it would deliver something. Sometimes it's so successful, sometimes not. It's really a hit and miss. It's unpredictable, which is the human side of it, right? You ask somebody and they may say something, may not. Political debates, they evade the question and go somewhere else. Because it comes from human data, so you would expect, human-like response. That's my very basic explanation for this. Sure.
So the questions about the longer captions, maybe the second or the third tier. So I think I remember one of them actually talking about, say, the Swiss and about certain things about Switzerland. Did you check? Is it actually correct? Reflecting what's in the data? Or is that just because the model might see the same text before, so they just use it there?
In the data, it usually was correct in the data, but then sometimes the conclusions drew from the data were not correct. Sometimes. There was I think it was Swaziland, or there was Botswana was another one. And it had a higher health ranking, but then it somehow explained it wrong. It has also problems with double negatives, big time problems with double negatives. When you ask a question with double negatives, it gets really confused.
Okay.
Then you can easily trick it. Of course, not the purpose if you don't make a good caption. But fact checking is good. It's good to fact check a little bit. Sometimes, most of the time, I didn't do a long study where I can say 10% are wrong. We only really did with three cases.
All right, let's thank the speaker, and we're going to move on.
Okay.
And hopefully we'll have time during discussion to revisit these topics.